am Andy Hopper. I'm Professor of Computer Technology, and I first joined the computer lab in 1974 as a research student, and here I am 2021 still at it. In the 80s, 90s and a little bit beyond, I worked at Olivetti Research, which became AT&T Research eventually, at the same time as being in the university. Well, the way the active badges came along is that we had moved the industrial lab, which was collaborating with the university, from a small office to a big one, and we were slightly lost, couldn't find each other. Somebody had the idea, maybe we can design some kind of a simple tracking system so we can find each other.
Well, howdy. Let me tell you about the Active Badge project here at Olivetti Research in Cambridge. Now, the Active Badge project is one of a number of projects we have here which deal with location of personnel and equipment to generate information which makes it possible for computer and communication systems to be easier to use. Now, active badges are personal devices like this one, which we wear. They transmit and receive in the infrared spectrum to transceivers, base transceivers such as this one. And this information makes it possible to define infrared cells which correspond to working spaces. Now, the active badge information is made available to everybody throughout this organization. And one of the systems it's available on is the Unix system. And here is my Unix window, X window, which shows what's going on in the company right now. So here is a list of all the individuals here, our visitors today. So for example, my colleague Mark Chopping is shown as being on extension 434. This column indicates whether he's moving or not. The 5 asterisks mean that all the recent sightings have been in one place.
So there was no location system, location sensing at that time. This was the first such system. And furthermore, there essentially weren't any mobiles. GSM, as a mobile technology, was only just coming in. So it was fixed telephones, no location systems, and the only other thing that was kind of comparable and a little bit of an inspiration for the active badge system was that GPS had only just come in for the general user. But that's of course outdoors, and this was our attempt at a similar system but for indoors. So a number of interesting uses of the active badge system became popular. In a sense, the most provocative but the most popular one was that on every computer system one could look up where somebody else apparently was, and most of the time this was true. And therefore, if you're working in a team, and this was all about teamwork, it became very convenient, indeed addictive, to check where people are if you want to interact with them. And the point is not to waste your time trying to find them if they're not available. The real sign that there was something to this is that for a period of 2 or 3 years, PhD students in the department, whether in their offices but perhaps mostly in the pub, would only talk about location systems and what they can do for you. And this really went on. Now, those students weren't only students on this particular project, because everybody in the department could use it, so it was all PhD students had access to it. And of course, they went on with their careers to their companies, senior positions in large companies and so on. And so that intellectual and also engineering perspective spread out and infected, I would say, for the very good, many other uses, many other companies, many other applications of such technologies. The system was not only installed here in the computer lab, but we the industrial lab, installed it at Xerox Palo Alto Research Center, Xerox PARC, and also Digital Equipment Corporation Systems Research Center in Palo Alto. So there were two industrial labs who were also participating in this project, if you like. They had purchased the system. So that's one way these things spread. There is a direct line between this work and the current location-aware, context-aware systems. And that is that the engineering side of this is not straightforward. Whether it's the energy management in mobiles, this is an early mobile. Whether it's the distributed system aspects where it has to scale to work across the planet with a very large number of devices. The roots of all that are in this technology, this set of things. But it's even more forward-looking than that, I would suggest. One of the challenges we all face is net zero sustainability, energy. And my perspective on this is that using computer sensors to sense the planet and then optimize whatever we're doing on the planet by way of feedback, well, that's a very similar sort of thing. So imagine, and I'm being quite serious, if we have a model and we're monitoring every tree on the planet, every single one of the 5 trillion trees, and something's observing it, producing events. Maybe we have a computational model which is a digital twin of the tree, all the trees. So we're modeling what's happening. Does it need love? Does it need nutrients? Does it need water? Doing that at planetary scale. Some of the thoughts are exactly the same, but in the computer system sense, the numbers have got much bigger.
I am Cecilia Mascolo. I'm Professor of Mobile Systems in the Department of Computer Science and Technology. When I started working with mobile devices, there were small portable devices and they weren't quite in the hands of everyone. And I think the appearance of the smartphone has kind of changed this, and it's in everyone's pocket and has sensors that can detect our behavior very accurately, including location and tracking of our health. And for example, one of our recent applications with mobile devices has been the recording through the microphone of COVID-19 sounds. So cough, we ask people to cough and breathe and read the sentence on the screen, and we try to understand if we can detect through machine learning the fact that someone has COVID. And since then, now devices are becoming smaller. We have watches appearing on our wrists, and the next generation, the way I see it, and it's already out there, are the sort of wearable devices that people wear in their ears. We've started working on them, and this is one of our prototype, trying to explore the kind of sensors you can put in these very, very small devices. And one of the projects is in fact related to using the microphone that sits inside some of the earbuds. Some of them have this rubber part that you put inside your ear, like here. And by using the picked up vibrations in the ear, we can detect movements of the body, for example, activity of someone walking. But these things can also go further, and one can think of possibly detecting heart rate from this sort of sensors directly from your ears. So all of these devices that we wear could be very useful in tracking someone's level of fitness, which is very much linked to health, in particular cardiovascular health. Some of the most recent wearables have a microphone that is that goes inside our ear, and we can use that to detect more accurately things that relate to the vibration of the body when we move, and therefore track activities. And in addition to activities, we can track gestures. So if I do this on my face, I will be able to detected through the sensor, but also we are exploring how we can also detect breathing and respiration sounds as well as heart sounds through that. And this leads the way, opens the door to tracking health in general through these devices and tracking it in a sort of affordable, less intrusive and more scalable way. Most importantly, I think tracking an individual continuously could be quite useful. When in health, we're used to go to the doctor and the doctor monitors us for a few seconds, and then we are back there perhaps in 2 months or a year. The ability to have a continuous signal about our health is what I think makes wearable health really, really valuable.